All right, we'll go and get started. Um, if if people come in and have questions about earlier stuff later, we can always come back to it. All right. Before I actually start, I want to just kind of give you a quick like overview of what this actually is, because most people are really new to this. All right. So I want to go through what we've covered just as a quick review, take a couple minutes, and then I want to go over each individual problem. And as you have questions over each problem, as I'm doing them, then you can ask questions as I do them. All right. If I need to regenerate more of these questions, I can do that. It'll take a couple minutes, but we can do that. Um, this isn't meant to be like me teaching you how to do every single thing. It's more of just a review of it. All right. So I've taught all of that before. Now it's just reviewing. All right. But hopefully this can at least structure a little bit of what you're going to study. All right. Now, keep in mind, this is a quiz. While this is the first quiz, so it seems like it's going to be worth a lot. In the grand scheme of things, it's not that huge. All right. Plus, it's all stuff that we've gone over before. All right. At least in past years. All right. So if you would like, I would recommend having this out in front of you. Okay. So at least like write down the problem or try and do this along with me so you're not just watching. Right. Because tomorrow you're not just going to be watching me doing these things. You're going to have to do them on your own without help. Okay. So again, just keep that in mind. This can be found in OnCampus if you want it. Of course, it's always right in front of you, though, too. All right, so first, a couple things, just topics covered. All right, so we went over briefly lines, specifically slope, intercept, and point slope. Okay, you have definitely seen slope intercept a lot, especially in the last 3 years. I know for a fact that each year you've gone over this at least for the first couple weeks of the year. Okay, so we should know that pretty well. All right, M is the slope, and B is the y-intercept. Right, so that point will always be 0, comma, whatever B is. For point slope, it's slightly new. It's a little bit easier of a form to work with, especially if you're dealing with fractions. Right, M is still slope, but we're dealing with the point x1, y1, and the regular y and the regular x just stay there. Okay, so you have a point, you plug it into x1, y1, you plug in your slope, and then you're done. Okay, besides that, we went over a little bit of factoring. Again, you guys should have seen this in past, especially last year. Maybe a little bit toward the end of Algebra 1, but definitely last year. Right, so factoring, we're trying to get something times something else is equal to 0. And then we solve. All right, I've got an example of that. We will go over that. After that, we went over inverses. So that's probably the most recent thing besides circles. That's where you just swap x and y and then solve for y. Right, so you're pretty much undoing the equation. That's the idea behind it. Then we just went over circles. We have this standard form of an equation where hk is the center and r is the radius. And with that, we also found distance. And those two things are related. Right, so d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's cut off a little bit, but I'll rewrite that once we do it. Okay, besides all those things, again, a little bit of a recap. We went over different parent functions, the ones that we need to know, like x squared, x cubed, absolute value of x, square root of x, right? So those are all things we need to know and what they look like. And then function composition, right? So there's only going to be one of these on there because most of all of this other stuff is using function composition just kind of in the background. All right, so that's what we've gone over. And I know that seems like a lot. Again, I think like 70-80% of this you've covered in past years. So this should all be a review. All right, so I want to go over how to do each one of these and what kind of I'm expecting. Get a good color. Yeah. All right. So the first question, really the first two questions have to do with lines. The first one has to do with distance though as well, and that's the only distance problem on this. Okay. Now some other questions might deal with distance, but this is the only one that explicitly deals with it. But first, let's tackle part A. Right. So it says write the point slope form of the equation of the line through the given points. Step one. Okay. So anytime we're dealing with an equation of a line, we have to find the slope between the 2 points. Right, so we just find the difference in y's and the difference in x's. So -1 minus 5 divided by -1 minus 1. So we get -6 over -2, which is equal to -3. All right, so that's worth a point right there. All right, so this is a 4-point problem. That's worth 1/4 of the credit. Okay, then in order to get the actual equation, we just plug in, we'll call this one x1, y1, and this is our slope. So we just plug it into this equation right there. All right, so we get y minus 5 is equal to -3 times x minus 1. And that's our answer for part A. Then there's the distance. So distance, again, we have an x1, y1, and an x2, y2. So we just plug that into the formula. So x2 is -1 minus x1 squared plus y2, which is -1, minus y1, which is 5, square that. And then you just simplify a little bit. So -1 minus 1. I'll scoot this up just a little bit. It's -2 squared plus -6 squared. -2 times itself, that's +4. -6 times itself, that's 36. So this whole thing is equal to the square root of 40. All right, this answer is good for now. In later weeks and later months, I'll have you simplify that. But for now, this works. All right, so 1 point for slope, 1 point for the equation of the line, and then 2 points for this distance. All right, number 2, write the slope-intercept form of the equation. All right, given the certain point and the slope. All right, so we have -2, 0, and we have the slope -3 fifths. Okay, this is not a y-intercept, so we have to do a little bit of work. There are 2 different ways to do this. I'll show you the one I would use, and actually I'll show you, well, yeah, I'll show you the point slope form. Okay, so we have a point, we have an x1, y1, and we have an m. So let's plug it in a point slope form. So it's y minus 0 is equal to -3 fifths x, and then +2. Then really all you have to do is simplify. So y is equal to -3 fifths x minus 6 fifths. Number 3, again, dealing with lines, we want the slope-intercept form of the equation. All right, so this one is actually a little bit different, and I didn't realize it was necessarily this easy. All right, or this different, rather. All right, so this line always goes through x is equal to 2. So no matter what y is, x will always be equal to 2. So then our equation is just x equals 2. On your actual quiz, you will have something that looks more like this. All right, so let's say it goes through 4, 0, and -5, +1. All right, so we need to find the slope. We go up 1, 2, 3, and then we'd run 1, 2, 3, 4, 5. All right, so our slope would be 3/5. And our y-intercept is 4. Okay, so that's really an example of something that you would see. Now, we need to know both, but we'll see something more that looks like this. Okay, so that's all of the line stuff. For factoring, right, we want to factor this out and then solve. Okay, so for number 4, we need factors of -21 that add up to +4. Okay, so I'm thinking +7 and -3, right? 7 times -3, that's -21, and that adds up to +4. So then our answers are r plus 7 times r minus 3. That's equal to 0. And then you set each of these equal to 0 and get an answer. So r would be -7, and r is equal to +3. Number 5, a little bit trickier, all right, because our leading coefficient isn't 1. So we will definitely have a 7n and an n, but then we still need factors of 16. So let's try -2 and +8. All right, so we get 7n squared minus 14n plus 8n minus 16. Yeah, so that'll work, right? Yeah, so in order to check, just FOIL it back out. So we get 7n squared minus 14n plus 8n minus 16. Right, this middle term ends up being -6. So we get our original. All right, then we set each equal to 0. So 7n plus 8 is equal to 0. So n is equal to -8/7. And then n is equal to +2. All right, now finding the inverses. There's going to be 2 inverse problems, okay? And for each of these, I would find easier if you just wrote it in terms of y. And then do it this way, right? So the first step we need to do is we need to swap x and y. I'll go ahead and do that over here too. And then we solve for y. Okay, so in order to get y by itself, the first thing we have to do is subtract over the 3. Then we need to get this denominator. We need to get this denominator outside of the denominator, right? So we multiply that by both sides. Then we need to get rid of the x minus 3. So we have to divide by x minus 3 on both sides. So y minus 2 equal negative 2 divided by x minus 3. Then we add over the 2, and we're done. Now, you could do all that. You kind of can take a shortcut. You should notice that this, and well, I guess it's down a little bit further. This y minus 2 and this x minus 3 switch places, right? So it's really just cross multiplying and dividing. That's what it ends up being. Okay, so this y minus 2 ends up being in the numerator. This x minus 3 ends up being in the denominator. All right. 1 on the right. Again, first thing we got to do is subtract that 3. So we get x minus 3 is equal to the cube root of y. In order to undo a cube root, you have to cube both sides. So then y is just equal to x minus 3 cubed. Okay, so I want to pause there because I know that's probably the most different thing that we've done so far. All right, so are there any questions about inverses? Okay, again, if we need to do more of those, we can. But let's kind of get through the rest of this practice quiz, and we'll come back to what we need here in a minute. All right, so this next part has to do with circles, parent functions, and then function composition. All right, so this circle one, this is what we just did. This is what your homework was over, which everyone did really well on. All right, I'll write the equation. Right, so r squared, the radius squared, is equal to x minus h quantity squared plus y minus k quantity squared, where this center is just hk. All right, so this first one is really easy. You're just plugging in this h and this k along with this radius. Okay, so you get 9 squared is equal to x plus 6 squared plus y minus 8 squared. And then 9 squared is just 81. So you could do that. You can write 9 squared or 81. It's kind of up to you. Next one is a little bit trickier because it just gives you the center and the point on the circle. Okay, so we need to find the distance from the center to that point. So if we do that, I'll do that over here. The distance from negative 7 to negative 14 is negative 7 minus a negative 2 squared plus negative 14 minus negative 14 squared. Negative 7 plus 2, that's negative 5. And then all this just becomes 0. So the distance is equal to the square root of 25, which is just 5. So our radius is 5 units. All right, and then we have all we need. All right, so 5 squared is equal to x plus 7 squared plus y plus 14 squared. And again, you can write 5 squared as 25 if you'd like. So there will be one problem where you're given the center and the radius explicitly, right? So you don't have to find anything. And then there will be one problem where you're given the center and then something not as explicit as the radius. Something that gives you enough information for it, but not necessarily r is equal to this, right? You have to find r. All right, 3 through 5, the second 3 through the second 5. Identify the parent function f of x and write an equation for the function given. All right, so this is where we need to know what the parent functions look like. Okay, so number 3, this parent function is the square root of x. This function is backwards, right? It's going the opposite direction because our original looks like this. And it is shifted left 2 units. Okay, so these two things give you the directions to write an equation of it. Right, so our new equation, because it's backwards, that means the input is negative. And because it's being shifted left, that means we're adding 2 to the input. Right, so negative inside and a plus 2 inside. So then this is our new function. Again, if you have a calculator, you can check that as well. Number 4, again, our parent function is the square root of x. But this time it's upside down. And it's shifted up 1 unit. Because it's upside down, we have a negative outside. And because it's up 1, we have to add 1 to everything else. So then this is our new function. Again, you can check that on a calculator. Number 5, we're dealing with f of x is equal to x squared because it's a parabola. It is upside down. And it is shifted down 2 units. Okay, so because it's upside down, we have a negative x squared. And because it's shifted down 2 units, we have minus 2. All right, so again, I want to pause there for a second. If you have questions over these transformations, let me know. One thing you won't see on this is shifts and shrinks. It's a little bit harder to do on graphs like this. So we're not going to worry about it for now. All right, we're just going to be dealing with shifts up and down or shifts left and right. All right, and while I give people a second to think, I'm going to write down the rules. I had the wrong thing muted. All right. Yeah, so those are the rules written in green. Again, we've gone over this stuff. It's been a couple weeks, but these are things we should know, just applying a couple of different concepts to it. Okay, so if you add something to the outside of a function, you're shifting it up or down. If you're adding something to the inside of a function, you're shifting it left or right. If you make a negative outside the function, it's upside down. And if you put a negative inside the function, it goes backwards. All right. So those are the things that I'm going to be expecting you to need to know. And we're not going to worry about shifts or shrinks. Okay. So moving on just a little bit to the last problem. All right. We have a function composition problem. Right. So really what we did up here is function composition, but I'm going to make you do it kind of explicitly on the last question. All right. So on this, we're given f of x is equal to 3x squared minus 4x plus 3, and g of x is equal to 4x plus 2. Okay, and in each of these, well, for this problem, I want you to find f of g of x and g of f of x. All right, now I want to take a quick step back for f of x. What this is saying is for this function f, if we input x, we have to square that input, multiply that input by 3, minus 4 times the input, and then we add 3. Okay. For g of x, or for the function g, if we input x, we multiply that by 4 and add 2 to it. Okay, so x is just an input. Okay, and the function tells you what you're doing with that input. So for f of g of x, we have f of 4x plus 2. So our new input is not just x anymore, it's 4x minus 2. So this will equal, right, 3 times 4x plus 2 squared. Right, that's our new input. Minus 4 times 4x plus 2. Again, that's our new input. And then we have to add 3 to the outside. Okay, that right there will get you most of the credit. I would expect you to simplify, or at least most of half of the credit. All right. So then we can simplify a little bit. And that ends up being our answer for part 1. Okay, for g of f of x, it's a little bit easier. We have g of 3x squared minus 4x plus 3. So again, this is our new input into g. So we have to multiply that by 4. And then add 2. And again, f, this function is our new input. So then we simplify that. We get 12x squared minus 16x plus 12. And this plus 2 is still here. So we have 12x squared minus 16x plus 14. And then that's our answer. So that is like a regenerated practice quiz. I want to give people a couple minutes to kind of think through it. Where do you get 4 from? Where do I get 4 from? I'm guessing you mean in this. Okay. That this 4. I'm assuming you mean this 4 right here. That 4 comes from up here, from our equation g of x. Yeah, that comes from our function g. So our original function g is it's just 4x plus 2, right? So that's 4 times an input. Right, again, 4 times our input. And then add 2 to it. I think that answers your question. Does that make sense? All right, so I'll leave this up. As you have questions, I'll leave this open for 5 minutes, and if there's no questions by then, I'll end it. But if you have questions up until then, by all means ask, and I'll spend as much time as I need to. All right, so take a second, kind of look over this. I'll scroll back up, and then I'll scroll down slowly. Okay, and if you have questions, let me know. All right, so I'll mute myself, and then as you have questions, just ask in the chat. All right, so since there's no one else on and there's no more questions, I will end it. So thank you for watching if you've made it this far, and good luck tomorrow.